Okay, hello everyone, it's Salar and we are in part 31 of our tutorial, a tutorial to writing a real-time operating system. And in previous parts, we talked about local variables and global variables, and now you know that your compiler allocates memory to your local variables in the stack frame of a function, okay? And compiler and linker in relocation parts, okay? In relocation part, allocate memory to your global variable in, for example, .data.ess.ro data or other user-defined sections. Okay, but in this part, I want to talk about dynamic memory allocation or runtime memory allocation. Okay, local variable allocation in compile time, global variable allocation in compile time and link time. But in this time, I want to talk about runtime memory allocation and why we need to allocate a block to a memory or a variable or array in runtime. Okay, sometimes we need to allocate memory to our variables or arrays in the runtime. Okay, to find out what we need to do allocation in the runtime, let's see for an example. Let's inspect this example. Assume that I want to read some integer number and put in an array in this part of my code, okay? But before running the code and in the compile time, I don't know how many number we will want to read, okay? Because we get the size of this for statement at the runtime by scanf, okay? So in the compile time, you don't know how much is the size, how many number you want to read, okay? But I allocate a 1 kilo int or 4 kilobyte array in my function. But assume in the situation, in one situation, the user enter the size equal to 10 integer number, okay? But the size of array is 1024, 1 kilo integer number. In this situation, size equal to 10, you have wasted a lot of memory, okay? But, or in another example, assume that the user enter 2000 for the size. In this situation, you have no enough memory and size to read all of your integer number from input. Okay, so in this situation, I need to allocate memory to my array in the runtime. Okay, like this example with dynamic memory allocation by malloc function. And malloc function, if you want to use malloc function, you need to add this include to your code, okay? stdlib. Okay, malloc function is a function that's defined in newlib, a library by GCC compiler, okay? It's a predefined function, okay, in this header file. But let's inspect this code. In this time, I don't have an array, I just have a pointer that will point to the start of my array. And another time, I have a size that I want to get the size in the runtime. Like before, get the size by scanf function in the runtime, okay? But in this function, after getting the size, you can allocate a memory to your array by malloc function, okay? Malloc get a unsigned integer number as its argument. What is this argument? size in bytes, number of bytes that you need, and return a pointer to the block. Okay, for example, assume that a user entered size 128 integer number multiplied by size of int in byte is 4. User need 512 bytes for its array, as much as he or she needs. Okay, and after that read all of integer in this for statement, do something on array, and after that give back this block to the memory allocator by free function. Okay, in this example, by malloc function you can allocate a block as much as you need. For example, here 512 bytes for 128 integer number. Okay, and free this block means give back this block to the memory allocator. When you use malloc function, this function allocate memory from heap section, a section in the SRAM, for example, in my microcontroller. Okay, here is dynamic memory allocation on runtime memory allocation from heap memory. Okay, so by malloc function you can allocate a function, you can allocate a block as much as you need and give back to the memory allocator. Okay, there are another functions in newlib for memory allocation, for example realloc or calloc or other functions. Okay, you can study about them on the internet and documentations. Okay, but to talking about concept of dynamic memory allocation, I just talk about malloc function. Okay, so what is heap memory or heap section? When you use malloc in runtime, this function malloc allocates memory from heap memory or dot heap section. But where is that heap section? In my memory, in my memory layout. For example, assume that here is my microcontroller memory. Okay, and here is my SRAM. Okay, as you can see in the SRAM you have that data, as you know, or that PSS, and after that PSS you have that heap section. Okay, that heap section and size of this section has been declared in the linker script. And as you know, at the end of the bottom of your SRAM you have your stack memory. Okay, in your SRAM you have, for example, .data.pss. After that PSS you have that heap section, and in the bottom of your SRAM you have your stack memory. Okay, but let's talk more about heap section. As you know, the boundary of your stack has been declared by stack limit and stack top in linker script, and boundary of your heap memory is defined in linker script by these two variables. End is the start of heap memory. End is a start. What is this contraction? I will talk about this end in next slides. Okay, but the end of heap memory in linker script is heap limit. Let's see our linker script and see these boundaries. For example, in Eclipse workspace, C project, here is my linker script. Okay, here is my linker script. Okay, as you can see at the bottom of your SRAM you have your stack memory, and after BSS section. Okay, BSS2 it can be a user defined BSS section. Okay, but it is useless in my project. Okay, for example, you can have another BSS section in your SDRAM, one for example in your RAM and one for example in your SDRAM. Okay, but it is useless in my project. After that BSS, I have heap memory. Okay, heap memory. And or here n is the start of my heap memory. I have my heap size. Heap size has been defined here in my project. For example, here heap size, okay, and stack size. You can change these sizes, okay. Here is heap size, and after that heap limit at the end of my heap memory. What is this point? For example, here, this point in linker script is location counter. When, for example, you put point in a variable, you put the address of this point to the address of this variable. Okay, address of this variable, for example, here, point to the start of your heap memory. Here is location counter. I've said I will talk about ELF file in future parts, okay, don't worry. But in this time, end is the start of my heap memory and heap limit is the end of my heap memory. Okay, I will talk about provide in next parts, okay, in next slides in this part. Okay, so okay, so what is heap block? When a malloc function wants to allocate some memory space that you want, for example, assume that you need, in this example, 512 bytes of memory. Okay, in the payload you need 520 bytes of memory. For example, here I need 512 bytes memory, but memory allocator adds this word in the first of block and has some information about block. For example, bit 0 give information about this block is allocated or free. For example, when you allocate a block, this bit is 1. Okay, and size of block, okay, size of block, all of block in double word align. Okay, size of block in double word, and a padding to make the block align to double word align. Okay, this padding increase the size of block to double word align, to a double word align size. Okay, if the size that you need here, the size, if here the size that you need in the payload is smaller than or equal to 12, the block size is 16. Okay, the block size is 16. But if the size is greater than 12, the block size is size plus 4 and align to next double word. Okay, let's give you some information in Eclipse. Okay, assume, for example, in this example, I want to allocate 2 blocks in heap memory. One is 10 bytes and another is 32 bytes. Okay, and put the start of payload in this pointer. Okay, let's run these 2 lines. For example, the start of payload for this block is here. Okay, this address, and start of payload for this block is this address. Okay, so the return value is the start of payload. Okay, not start of block. Okay, but I want to see this information, these informations in blocks. Okay, in this example, I can copy this address, open memory, and paste it here, -4. Okay, -4, because this address, return address from malloc is a startup payload, but I want to see a startup block, -4. Okay, okay, and this block, another time, address -4. Okay, for example, for this 10 byte, in the first byte of block I have these two numbers, okay, 1 1 in hexadecimal. Okay, for example, for 10 byte it's 1 1 1 0 0 0 1 0 0 0 and 0 0 0 0. Okay, this 3 bits is 3 bits. Block is allocated, and size of block in double word is 2 double word. 2 double word is 16 bytes. Okay, so in this block, 1 word for information about block and 3 word in the payload and padding. Okay, but for example, for 32 byte, here is 29. Let's do see here 29. Uh, 29. Okay, 9 and 2. 9 is 1 0 0 1, 2 is 0 1 0 0. Okay, block is allocated, and size of block in double word is 5. 5 multiplied by 8 is 40. Okay, I need 32 byte plus 4 is 36. Align to double word, next double word is 40, size of block. Okay, so when you want to allocate some bytes in heap memory, your memory allocator creates this block in the heap memory. Okay, a part for payload that you need, first part, first word for some information about heap block, and some padding for align to next double word. Okay, now let's talk about these boundaries. Okay, and heap limit and other boundaries. Okay, your library defined this function, sbrk function, in newlib. Okay, in newlib, and the malloc function uses this function to check these boundaries. Okay, to check these boundaries when want to allocate memory. Okay, after a start, before allocating any memory. Okay, for example, assume that you have allocated no memory in heap memory. Okay, first heap end point to the start of your heap memory. Okay, so after a startup, end is in the start of your block. Okay, heap end is a variable that's defined in this function, for this function. Okay, and end and heap limit defined in linker script. So before allocating any memory, heap end point to the start of heap. But assume that you want to call a malloc function for this size. Before allocating this block in the heap memory, sbrk function increase the value of heap end. Heap end first of block plus block size that you need, plus block size, not payload size. Okay, plus block size. So now after allocating this block in the heap memory, heap end point to the end of allocated block. Okay, and heap end point to the end of allocated block in your heap memory, not end of your heap memory. Okay, because of that here I have this name, heap end or end. Okay, end is a constant variable that point to this address and heap limit, but sbrk function change this value. First, heap end is equal by end, but by allocating memory to the heap, the sbrk function increase this value until heap limit. Okay, until the size of your heap memory that you have. Let's see more examples. For example, assume that you have allocated a block in your heap memory and heap end is here. If you want to allocate another block, you need to another time increase the heap end from here to here by sbrk function. sbrk function is a predefined function in your library. Okay? Or this example, assume that you freed this block, allocated 0, okay, and you want to allocate another block, block 2. If the size of this block is smaller than allocate 0, malloc put the block here in the free space. Okay, put the block here, puts the block here. But if the size of this block is greater than allocate 0, malloc can't put the block here because here you don't have enough space. So increase the heap end and put the allocate to here. Okay. Okay, I said this function is predefined in newlib. Okay, let's see this function, for example, in GitHub. Search in GitHub newlib in GitHub. Okay, open the source of this project in GitHub, go to libgloss. Okay, libgloss. Go to the ARM for ARM architecture and open syscalls. Okay, open syscalls. Search for sbrk function. Okay, you have sbrk function here and it's predefined in newlib, but this function is a weak function. And because this function is a weak function, you can redefine this function in your project, and it's better to redefine this function in your project for your linker script. Okay, because this function is completely related to your linker script file. Okay, so you can redefine this function according to your linker script. For a standard linker script, you can use a standard function, okay, predefined function, but I want to see you some information how you can redefine this function. Okay, now I want to redefine this function sbrk. Take an argument. This argument is size of block that you need. Okay, for each block you need to increase heap end. Okay, increase heap end by this size. Okay, so in this function I want to use these variables from linker script. Okay, these variables defined by a linker script. Okay, these variables, the start of your heap block, start of your heap memory and heap limit. Okay, end of your heap memory. Okay, let's another time see the linker script. As you can see, I have end here and heap limit here. What is this provide? When you use this provide in your linker script, okay, your linker define this variable, your linker define this variable as a weak variable, okay, as a weak variable when you want provide, okay, and you need to write this extern to have access to this variable, okay. It's better to change this variable to provide. You don't change that, but it's better to change that, okay. Because if you don't write this provide linker script and your linker define this variable as a string variable, okay, but it has some difference between this variable without provide and a string variable, okay. For these problems, it's better to define and change this variable to this form by provide, okay. Sorry, you should put parentheses here, okay. So here, like and is a weak variable, okay, and save that, and you can use extern to use this variable from your linker script, okay. Now I have the start and end of my heap memory from linker script, okay. So I have another variable heap end, another pointer that is initialized to 0, okay, heap end, okay, I have heap end, okay. I have, and in my function I have a local variable previous heap end pointer, okay. I will talk about that a bit ahead, okay. But at the first of allocating block, okay, before allocating any blocks, okay, in the first of allocation, when your heap is free, when you have not allocated any block, heap end is equal to the end, okay. So you should put, if the heap end is 0 in the first, you should address of at the start address of your heap memory in the heap end, okay. When you want to have the address of a block with a variable that's defined by linker script, you should use this ampersand, okay, because this is a variable, this is not a pointer, okay. You need to use this ampersand to have the start address of your heap, okay. So it's better, for example, here write ampersand end, okay, because end is a variable, is the first block of heap memory, and ampersand end is the address of, is the start address of your heap memory, okay. So you need to write ampersand end. So after this if block in the first memory allocation, the heap end equal to end, okay. So for each increasing, your malloc function call this function, and this if is so important, okay. This if is so important. If heap end plus increase, the block size that you want is greater than heap limit, another time with ampersand, okay. I said you need to use this ampersand, is if heap end plus increase is greater than or equal end of your heap memory, or if the heap end plus increase is greater than or equal a stack pointer. Why a stack pointer? Because sometimes your stack cross this stack limit, and sometimes even cross this heap limit, okay. You have a big stack, you need a lot of stack, sometimes your stack cross this boundary and this boundary, okay. So with this situation, you need to check the heap end plus increase by your stack pointer to avoiding stack overflow, Okay, here is a function from CMSIS, and with this function you can get the stack pointer value. Okay, if the heap end plus block size is greater than or equal to heap limit or stack limit, return -1 and put this value in error number. Okay, here is a standard error number in newly library. Okay, return minus value from this function shows that you have no space to increase the heap size. Okay, but if you have enough space, heap end plus increase, heap end, for example, plus increase, and return the previous heap end. Why we need to return previous heap end? Because it's a standard from newly. You can study about these functions on the internet and documentation. Okay, but for example, if you call this function by 0 because of this previous heap end, you can find the heap end. Okay, it's one of its application, but you have to redefine this function in this form according to your linker script. Okay, for example, here in my linker script I have end and heap limit. Okay, and I can redefine this function because this function is a weak function in the new lib. Okay, in this way you can redefine brick function. Okay, here was an introduction about dynamic memory allocation and malloc and free function. Okay, and neolib. Okay, now you know how you can have local variable, how you can have global variable, where is your local variable, where is your global variable, and where is your dynamic memory block. Okay, with local variable you can allocate memory in compile time. With global variable, your compiler and your linker by relocation allocate memory to your variables, but you can have runtime memory allocation by malloc function, and you can free that and give it back to the library by free. Okay, here was some information about malloc and dynamic memory allocation. Thank you very much to see me, and see you soon in the next part. Thank you very much.